tell you, many teachers, everyone's watching me, Chris is watching me, there he goes. Many teachers teach this unit and they start with the easier problems and then they go to these, the harder ones. I'm about to show you the easier problem. And you're going to look at it and think, if you had seen this on the SAT or the PSAT last 2 weeks ago, you honestly would have said, I'm out. I'm not doing it. I'm going to mark C because you can't go wrong with C. C is always a good answer. Here is the problem. Take a look. If on your paper, you can read it yourself. But most of you would look at this and say, nope, not doing it because it looks terrifying. I'm going to read it. A rectangle is inscribed in the triangle formed by the X and Y axis at the line y equals negative 2x plus 10. What is the maximum possible area for the rectangle? Honest to God, you'd be like, and done. And here's why you would say that. Are you guys ready? You would say that not because this problem is hard. It's because when we do real life stuff, if I say build a pen for a goat, you know what the hell that looks like. When I say this do, you're like, I don't even know what you're talking about. So today, I am going to break this down, and then when we do it, you're going to be like, oh my God, this is literally easier than last night's, but it looks super scary, okay? So all we're doing is taking what we did last night and putting it in a math context, not a goat context. So the first thing I want you to do is either on your paper or on your whiteboard desk. Here's what I want to start with. The first important word is this. We are graphing something. So can you make the X and Y axis? And it doesn't need to be perfect. It just needs to be a random X and Y axis. So we're doing our X and Y axis on our whiteboard or on our paper. I don't care. And it doesn't even have to be like good. It has to just be like this. Yay. So for all of these problems tonight, we're going to have two things happening. We're going to have a weird shape, and we're going to be trying to shove a rectangle into it. That's what we're doing. We're taking weird shapes and shoving rectangles into them. So the first thing we got to figure out is, what's the weird shape we are shoving the rectangle into? And the weird shape tonight on this one is a triangle. And you're like, okay, how do I draw a triangle? And here's what I want to do. The only information they give us is this weird little line right here. So let's graph it imperfectly. Right now, take your little pencil, find 10 on the y-axis, wherever you think 10 is. Does it have to be perfect? It does not. Just randomly find 10. Boom, that looks good to me. Now let's do our slope. Watch what we're going to do. We're going to go down 2 over 1, down 2 over 1, down 2 over 1. Do that and draw that little line in. Again, does it have to be perfect? Not even close. And you know why? Because we're maximizing this. We're eyeballing it. Again, I'm seeing so many people like trying to be really good about this. Just down 2 over 1, down 2 over 1, down 2 over 1. Like, I don't even care. Like, just go like this, right? Because that part is not going to be important. So look what I have drawn on here. A triangle. Y'all see it? It's got a side right here, and it's got a side right here. And here's what we're going to do. You can put your pencils down for a second, because I don't want you to draw this on. We're imagining that I'm coming in and thinking, I'm going to try shoving some rectangles in there. And I shove my first, that just sounds so creepy the way I say that. I shove my first rectangle in like this. I shove them in there. I'm like, ooh, that's a good rectangle. And then I think to myself, ooh, I'm going to shove a different one in. Maybe I put this one in. Ooh, that's a nice rectangle. And then I think to myself, ooh, maybe I'll do a nice fat one with the little pink dots. Look at how pretty he is. Ooh, very nice. What I'm going to ask is, what's the biggest rectangle we could shove in there? And we're going to use math to figure it out. So what I'd like you to do is, I back this all out, I'd like you to shove in a rectangle into your drawing. I don't care how you draw it. Make it as big as you can. but shove it in there so it fits. It's inscribed, right? He doesn't get to get outside the triangle. He's got to lay right along the X and Y axis, and he's got to like touch at that line. Like, shove it in there. Make him as big as you think you can make him be. I'm gonna make him like this. I'm gonna make him like this. Yay. Yay. I put him like that. I think he's beautiful. Okay, so here we go. We're doing exactly what we did last night. We're maximizing area. Maximizing area. So we are going to need area as our formula. Last night, we did length and width because we did real life stuff. Oh, I just taped that. That's bad. But tonight, we're not going to use length and width because it's on this guy right here. So if this is the x-axis, what am I going to put here instead of width or length? What letter should I use? X. I'm going to use X. Awesome. I'm going to put X right there. Yay me. When I come up here, I'm not going to use length or width because I'm on the XY axis. What letter will I use? Y. Y. Awesome. Now, here's the gypsy magic. Do you guys agree that this Y and, check this out, this Y, are they the same? Is that the same side? Yeah, it's a rectangle. Yeah. Okay, here's where this gets good. And you're like, Miss T, you didn't give us perimeter. You didn't give us any of that stuff. Watch this. This point right here is on this line. Do you guys agree with that? And do you know what that line is? It is Y equals negative 2x plus 10. Is everybody cool with that? Have I tricked anybody? So watch this. My area is x times y, but I'm not going to write y anymore. What's y's new name? Negative 2x plus 10. Guess what? I'm done. Desmos is going to do the rest for me. You see what I'm saying? I got it down to 2 variables. They gave me what y is. I already know what it is. I'm just going to shove it in there. Is that cool? Okay. Let's pull up Desmos. Let's do it. La, la, la. Is it easy? It is. Am I going to use x's and y's? I am. So here it is. X, parenthesis, negative 2x plus 10, close my parenthesis. Oh, that was not a closed parenthesis. Okay, it's way the hell down here, like I'm at 1,000. Oh, I gotta go way down here. Oh, look, he's adorable. He's so little. I love him. There he is. Boom. Guess what? We're done. Because all this problem wants to know is, what's the max area? And what is the max area? 12.5. This guy right here. 12.5. If I wanted to give the x and y coordinates, what is the x coordinate? 2.5. X is equal to 2.5. How do I get the y coordinate? What do I got to do? It's not on the board right now. I got to do that dividing, right? So if you got a phone, if you got a calculator, you're going to just literally say 12.5 divided by 2.5. Comes out nice and pretty. She's pretty. She's 5. I told you, it's easier than last night. There's no moving stuff around. There's no counting all your sides. There's no barn doors. You just got to know the shape, and then you got to shove your rectangle in. You guys ready to try one? You ready for one for yourselves? Let's do it. Or together. Here we go. Okay, boom. New thing. First step, draw your x and y coordinates for me. Boom. Okay, last time I put a triangle on there. This time I am putting a upside down parabola. How do I know it's a parabola? Because I wrote the word parabola. How do I know it's upside down? Because I put it upside down. So I want you to go up to 6 and make your parabola drop down, right? Because that's an upside down parabola. You knew that because we've been doing that. So slam him on there. Boom, like this. Look, he's beautiful. He's so beautiful. Now what I want you to do, I'm going to walk around and look, shove a rectangle in there. But I don't want him to be the whole place. I want him to be laying right in the corner here. Does that make sense? Because it says it's on the X and Y axis. So shove him right here and make him touch. Does that make sense? Shove him in there. Beautiful. Love that. Love that. I love that. Love that. And guess what this point is? Right here. It is negative x squared plus 6. Do you see what I'm saying? And now you can actually kind of finish this, right? Okay. Do we have it shoved in there? Here's where he's going to go. I'm going to put him in just like this. Boom, 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 like that. Guess what that point is? It is y equals negative x squared plus 6. Because that's what it is. So now I'm going to say area is x times y. I'm going to pop out my y. I'm going to pop in my x. Area equals x times negative x squared plus 6. Now, can I ask everyone to do me a favor and put your pencils down again? I'm about to do something that you will never have to do again. Because the computer, Desmos, will do it all. But you're going to get a graph that looks a little weird. We've been getting U graphs, right? We've been getting U graphs and getting that max number. Watch this real quick. Just watch. Don't panic. I'm going to just do a little bit of this. Do you ever have to do this? No. No, Desmos will do it all for you. But I get x to the third, negative x to the third, plus 6x. Can you guys tell me what shape is an x to the third graph? Yeah, it's a lightning bolt, right? So when you put this into Desmos, and you're going to do that right now, don't be surprised if you get a lightning bolt, because you're gonna, right? And you're not going to look for the low part of the lightning bolt. You're going to look for the relative maximum, not the absolute. It goes to infinity. Put it into Desmos right now. There you go. I would do it this way because I'm lazy. I would just do literally this into Desmos, just like that. It's kind of a roller coastery kind of thing. Here's what, I'm so lazy. I don't go x squared. I just go xx because I'm that lazy. So xx plus 6. Look at him. He's beautiful. He's adorable. I love him so much. I love that guy. I literally love him. So here's what. He's not an absolute maximum because really it goes up forever this way. We want the relative one. And we want it positive because this is, positive. So here I go. I'm going to touch right there. I think the question doesn't even ask for the dimensions. I don't care on this one. I just want the area. And the max area of my little rectangle is 5.7. And you know what we put? We put units squared because we don't know if it's inches or miles or feet or centimeters. So we just put units squared. Okay. You ready for the next one? I think you can do the next one alone. I don't even think you need me. So the key on the next one is, what's the big shape? The big shape, I wrote it up there. Can you guys read what the big shape is? Half circle, half circle. So guess what? Draw a half circle. Shove your rectangle in there. Don't put it all the way across. We do that next. Just shove it right in there, right? You guys are doing great. I told you, it looks scary. but it's really, really not. And you know what this point is right here, so it will be y equals square root of 8 minus x squared. And then now you're ready to shove that into your area, right? Area equals x times y. Pop out the y, pop in there. Beautiful, beautiful. Just careful when you type it in. And it makes the most adorable graph. Type it in. It's so adorable. Wait till you see it. When you type it in, it's a really cute little graph. It's not like anything you've literally ever seen before. It's super adorable. I don't know why it makes that little graph. Right. Yes, yes, that's it. And isn't that fun? Oh, see, isn't he adorable? That's super adorable as that. He's super adorable. Did you get him? Look at him. He's like a little baby. Yeah, isn't he adorable? I don't know why that graph makes me so happy. I know, she's a cute little graph. X, y equals 8 minus x squared. A equals x times 8 minus x squared. You get really fast with these after a while. The only trick is Desmos makes you be careful. If you blow it putting it in, you're kind of screwed, right? So nice and careful when you do this. 8 minus xx. Oh, look how cute that is. I just love that. I don't know why. I just do. My max area is 4 units squared. And if you want to put the dimensions, it's 2 by 2. It's a cute little rectangle. Last one, best one. And then you're going to have time to work on homework. And I'm going to check off homework. And life is going to be good. And yay for us. And tomorrow we review. We have a Be Nice Friday. It's all good. Okay, last one, best one. Everyone's watching. It's a little bit new. A little bit different. We change it up a little bit. Okay, one more time. We got a parabola. So can you please draw me a parabola? It's upside down. And then stop. Then stop. Draw your parabola and then stop. Because we got a little bit of weirdness going on. Boom. Looks like that. He's good. He's lovely. Now, normally, I've been saying this. X and Y axis. Those are 2 of our sides. On this one, X and Y axis. Those are 2 of our sides. But on this problem, it's just laying flat on the x-axis, meaning we're stretching this one. We're going as big as we can fit underneath the parabola. So you're going to lay him on here and go all the way over as big as you can. So can you draw your rectangle in there? And here's what. He's going to, this time he's not just doing the little baby half. He's going the whole way this time. Stop. Straight. I'll give you time, and then you can finish it when we're done. Just you have to do this problem. Okay. So here's where this gets weird. You guys ready? Now, normally we know a couple things. We know that this is y and this is y. That's all great. And we know he touches right here at y equals -1/2 x squared plus 8. That's all awesome. Nothing has changed. But the bottom part is not just x times y. It's both of these guys. I need that whole thing for my area. So my area is not going to be x times y. That's not enough. That would just give me this much. How many x's do I have here? I have 2. So I need 2x times y. Does that make sense? Because really what I'm doing is I'm doing this guy, and then I'm timesing it by 2, right? I'm doing both halves. So it's the same problem that we've been doing. It's just when it lays flat, it just doubles it in size. So can you, with your table mates, finish this bad boy up, plug him into here, see what you get and go ahead and do that. And I think I've not even asked them dimensions. I think I just asked them that. 2 x. I use 0.5 because I'm lazy. Negative 0.5. Because you know what? I'm too lazy to literally do fractions. That's x plus 8. Oh, look at her. She's beautiful. She's super beautiful. There she is. There she is. Boom. I got like 24.6 for my max area. Is that bad? Okay. So here's what. I am going to check off homework today. So if you were flaky, finish it up right this minute and then do this at home. Your homework is these problems. You can skip number 4. There are only 5. So I need to do 4 problems. Skip number 4. It's just a random problem, right? If you are a smarty pants, so listen real quick. I want to say this. So Colton's listening to me. I love the fact that I can fund all my juniors. That's so adorable. I feel like I should dress like this every day. Here's what. Everyone's watching? So Zach's watching me for a second. Why? I know you're going to get time to finish. Don't worry. This is high school pre-calc. There is college pre-calc, which is AP pre-calc, right? The thing that gets you really ready for college calculus is college pre-calc. But it is possible to go from regular high school pre-calc to college calculus. But it's a big jump. So I recommend to the vast majority of my seniors, you will have a choice next year about what math class to take. And here was my recommendation. If you are going to be in a major that requires calculus, take college pre-calc first, because you will ace it. I get you very ready for it. And then go take your college calculus, because you'll do much better. If you are taking a major that does not require calculus, go to stats next year, and then that will be the last math class you ever take the rest of your life. Amen. Thank God, right? If you are a junior, though, you're going to have some choices about whether you want to jump up to calculus, or you want to go to AP Stat, or you want to maybe take college calculus. Some of you have a lot of choices. The reason I'm saying all this is this. On last night's homework, number 4 is a cool problem, but it's harder. So if you are a smarty pants and you are considering, I might go straight to calculus, then you need to be able to work your way through problems like problem 4 with your friends, with each other, right? So if you would like to do one less problem tonight and try number 4, you can do that as well. Is everybody cool with that? So skip number 4. If you're a smarty pants and you want to try that other one, skip another one. I'm checking that one off in a minute. I'm done talking. Yay, goodbye to my people who